DeepSeek's new model just solved a physics simulation problem that was supposed to be impossible for AI, and nobody's talking about what it means. So here's what happened, and why it's actually a bigger deal than the headlines are making it. A few weeks back, DeepSeek released their latest reasoning model, and when researchers ran it through a battery of benchmark tests, something unexpected popped up. There's this test called P-Dynabench. It's a physics-based simulation challenge. Think of it like asking an AI to predict how a bunch of particles will move through space under different forces, or how a fluid will flow around an obstacle. These problems are brutally hard because they require the model to understand causality, spatial reasoning, and the actual rules of how the physical world works. For years, these tests were considered one of the few places where AI models genuinely struggled. Not because they couldn't memorize answers, but because they had to actually reason through a problem they'd never seen before. It's the difference between knowing the answer to a math problem and actually understanding why the answer is right. DeepSeek didn't just pass P-Dynabench. It crushed it. We're talking about a jump in accuracy that shouldn't have been possible with the current generation of models. And that's the part that's freaking out people in the AI research community. Not because DeepSeek is suddenly smarter in some flashy way, but because it suggests something fundamental has shifted in how these models can approach reasoning. Now, here's what you need to understand about why this matters beyond just another benchmark win. Physics simulation is one of the hardest problems in AI because it sits at the intersection of three things: pattern recognition, logical reasoning, and what we call compositional understanding. That last one is the killer. Compositional understanding means you can take concepts you've learned separately and combine them in new ways to solve a problem you've never encountered. A human does this naturally. You learn what gravity is, what friction is, what momentum is, and then you can predict what happens when you drop a ball on a slippery floor. You don't need to have seen that exact scenario before. For a long time, AI models were really good at pattern matching, but terrible at true compositional reasoning. They could tell you that a dog is usually near a leash because they'd seen that pattern a million times. But asking them to predict something genuinely novel, something that requires combining concepts in a new way, was where they'd fail. What DeepSeek seems to have cracked is a better way to do that composition. The specifics of how they did it are still being unpacked, but early analysis suggests it's related to how their model structures its reasoning process. Instead of just throwing more compute at the problem or training on more data, they changed the architecture of how the model reasons through a problem step by step. And that's the kind of shift that compounds. So what does this actually mean for you? Well, in the immediate term, it means physics simulation is about to get way better. That has real applications. Drug discovery relies on simulating how molecules interact. Climate modeling needs accurate physics simulation. Engineering, from designing airplane wings to predicting how buildings will hold up in earthquakes, all of this depends on simulation. If AI gets dramatically better at this, those fields accelerate. But there's a bigger picture here. Physics simulation is kind of a canary in the coal mine for AI reasoning in general. If a model can truly understand and apply physical laws to novel situations, it's also probably getting better at other kinds of reasoning. Legal reasoning, medical diagnosis, code generation, anything that requires taking abstract rules and applying them to a situation you haven't seen before. That's why some researchers are looking at this DeepSeek result and seeing it as a sign that we're entering a new phase of AI capability. Not just faster models or bigger models, but models that actually reason differently. And that's way harder to predict or control. Now, there's a healthy dose of skepticism worth injecting here too. One benchmark doesn't mean everything. It's possible DeepSeek got really good at this particular test and didn't generalize to other reasoning tasks. That happens all the time in AI. A model dominates one benchmark, and then you test it on something slightly different, and it falls apart. We need to see this tested across other domains before we know if this is a genuine breakthrough or a clever optimization for one specific problem. But here's the thing that's hard to ignore. This is the second time in the last year that DeepSeek has shown up with a model that does something researchers thought was further away. They're not the most famous name in AI. They don't have the brand recognition of OpenAI or Google. But they keep shipping models that make people go, huh, that's not supposed to work yet. And that pattern matters. It suggests the innovation is happening faster than the public narrative is keeping up with. So the real question isn't just whether DeepSeek broke physics simulation. It's whether this is a sign that the next leap in AI reasoning is closer than we thought. And if it is, that changes how you should be thinking about AI's role in the next few years. Not as something that's coming eventually, but as something that's already accelerating. If you want to actually keep up with AI breakthroughs like this before they hit the mainstream, subscribe. I break down what's actually happening in the AI world. Not the hype, not the fear-mongering, just the real technical shifts that matter. New video every few days.